Welcome once again. Now to discuss, usually we talk about the body control modules for accessories for lights. Toyotas and Hondas, they have now, what you see over here is a relay control module and a DRL control unit, which is for daytime running lights. As always, you start with the diagram. You always start with the most important components or symbols. What are the most important ones that stands out, that takes your attention right away? This takes your attention right away. Control block, which is in this relay control module. This is one unit. Here's the relay. Here's the relay. This is for low beam. This is for high beam. This gets your attention. Daytime running lights control unit. Of course, the bulbs. Of course, the bulbs for high beam, right and left. For low beam, right and left. But also now, this one over here, daytime running light relay. These catch your attention. That's what you focus on. Now, how they all mesh together. We have relays over here, nothing different than we had before. We always need a 12 volts. We always start from which side? We always start from the coil side. No resistor over here, as you notice. You're going to notice a few things. No resistor and also no pin numbers. Because all this is in a unit. So therefore, over here, as you see, we start with this one always. Even though all of this is in one unit. We still need this one to activate this one. The switch. This is in a rest position. Right now, no current flowing. When this has current flowing from the battery, which is hot at all times, we go through a multi-fuse 22 at 120 amps. Now, the question was asked, the bulbs don't take 120 amps. We have 1, 2, 3, 4 bulbs. And you have the model, and you have this one. This fuse is also connected to other systems. So it's a multi-fuse at 120 amps. This is not taking 120 amps. But what you don't see is the other systems that are also connected to this fuse out of this schematic. So now what we're concentrating on, let's say we want the low beam. We know we need a 12 volts and we know we need a ground. We have the 12 volts already through the fuse, the battery, through here. We need a ground. What's going to give us a ground? If you look what it's connected to, you see it's connected to what's in yellow, which is the control panel. This will give it a ground that it needs. When that happens, this is activated. Then this switch is flipped over here, making contact from here to here. That's great. Now we can go here, zoom back. You go to this one, which is low beam over here. This is low. LO is low beam. That's one side. We could go to the other side, low beam, which is the right. So we're activating the right and the left bulbs by this one giving this a ground. This one, now we need a high beam. Same scenario. We need a 12 volts here. We need a ground. Who's going to give us a ground? If he gave him a ground, why shouldn't we get a ground? He's going to give you a ground. When that happens, same scenario. Current flows here. This is now closed. Here. We're dealing with the green one. Follow the green. The green goes here, high. The other green goes here. So therefore, what we need this for is to give him a ground. This one and this one. The rest, when the current flows, it goes through the correct paths. As we said before, no pin layout, no numbers, because it's in a unit over here. That's number one. Number two, you don't see a BCM over here. You do only see this relay control module. How does this happen? When you turn on the switch. When you flip the switch, you want either low beam or high beam. Then it's detected. It's detected by this, and it gives the proper ground to initiate either the high beam or the low beam. Let's say we don't have the high beam and the low beam. Now we're stuck. Can the fuse be the problem? Of course, because the fuse feeds both of these. So it's a common factor for both failures. That's number one. When you have a problem with low beam, always look, do you have the high beam? When you have the high beam, look if you have the low beam. In this scenario, in this problem, we have both not working. We said it's the fuse. How about this connection over here? Fine. Can it be the control block? Yes, it can. It can be faulty. Maybe it doesn't apply ground to both. Can the relay be the problem? Well, if this relay was the problem, I could still have the low beam. If this relay was the problem, I could still have the high beam. So therefore, what's the common factor? Always look for the common factor to knock out both the low beam and the high beam. Besides that, we said this wire, but also this one over here feeds both. Can it be that it fails to give a ground to both? We don't know. But the only thing that's possible, that's common, is this control block. Also the grounds. Look at the grounds. Even though this is G201, even though this is G301, different grounds. So it's unlikely that the grounds will be bad because they're shared by two different ones. For the low beam. The high beam is a different story. This high beam shares this ground as the low beam. So if you have a problem with the left high beam not going on and the left low beam not going on, you might as well say it might be a ground because they're shared by both. This one is a different scenario. Q21 is the ground for the right one. However, look at the high beam. Here's the high beam. The high beam, where does it go through? Goes to a different one. Goes to a different circuit. Goes to DRL relay, the daytime running light relay. For him to work as a high beam, guess what? Your relay cannot be activated. This has to be in the rest position. If your daytime running light is on, he will not get a low. High beam cannot be turned on for this one. Because look at the current. Current flows here. This is good. It has a path to ground. Great. Because why? Why is it this in this position? Why is 1 connected to 4? Because this is not activated. What happens when pin 3 and pin 5 is activated? Now 1 is not connected to 4. 1 is connected to where? 1 is connected to 2. It'll go to another circuit. That's why you have to pay attention to see where everything is connected to. He plays a role also. Daytime running light, control light. He could be also a problem. He could be a problem. He could be a problem if this high beam does not come on. So you see, it's just not a fuse nowadays. It's computerized control units, relays, control units from here, and BCM control modules. Please go to my channel, Automotive Electronic Schematics by Joseph. Please subscribe to that, and also go to the other one, Joe Electronic Schematics for Auto. Well, you'll see more videos. Please watch those videos about how to test batteries, how to test resistance on those cables. Many times it's corrosion, as you know. Thanks for watching.